Hi guys, welcome to your 7th grade Unit 2 review. You made it to the end of your first unit. Congratulations. You might be wondering, especially if you looked at your grade book, it looks like it goes all the way from Unit 2, Lesson 7 up to Lesson 11. There were a few that were skipped, okay, so don't stress about that or anything. And with this review is tied directly to your test, okay? I modeled each of these problems off of the test that you're going to take in your next lesson, and so make sure to write these down. Use these as your notes, and that way you have examples that go through the exact same style of problems that's on your test, okay? So let's get into it. Number 1, -2 minus 6 and 7/10. Okay, so we got to remember, all right, when we are, one, we've got a negative here and we're subtracting, okay? So one thing we can remember is that, one, you could think to yourself, okay, maybe I borrowed $2 from my mom and then I borrowed another $6.70, right? So how much do I owe her? Right? Which means we're combining those two values to figure out how much do I owe her altogether. We can also rewrite this. We can think, okay, this is the same thing as -2 plus -6 and 7/10. Okay, and when it's set up like that, we can use the rules for adding integers. Okay, which if you look on my message board, there's a file on there, or there's a screenshot of the rules for you. So hopefully that can help too. But now, even this, it's like, okay, well now the signs are the same, so I can just add those together and then keep the negative sign, right? It's like adding two negative numbers, so I'm still in the negatives. So when I add these together, I get negative, and then here's a whole number plus a whole number, right? 2 plus 6 is 8. But then we still have 7/10 more than that. All right, so -8 and 7/10 would be your final answer. With this next one here, well, one, we've got fractions, we've got mixed numbers, okay, and we're subtracting a larger number from a smaller number. So there's a lot of things going on here. The first two things that you always want to check for is, one, are they mixed numbers? Yes, so we need to convert them to improper fractions. The other thing you always want to check for is, do they have a common denominator? In this case, they already do. Yay! So we don't need to deal with that. All right, so first let's convert them to improper fractions. To do that, you take your whole number and you multiply it by your denominator. So 4 times 4 is 16. And then you add in your numerator, so plus 1. 16 plus 1 is 17. I keep my same denominator. And then 13 times 4. Whew, that's kind of funky. But we can actually use number sense to get that figured out. 13 times 4. Well, I know that 12 times 4 is 48. So really, 13 times 4 would be just 4 more than that, right? I would add in one more 4, giving me 52. So multiply those together, add in your numerator. 52 plus 1 is 53 fourths. Okay? So this is similar to the first one in that we can use our rules of adding integers for this one as well. So we can think to ourselves, well, I have 17 minus 53, right, if I'm only focusing on my numerators. Okay, so I know I'm getting to 0, I'm subtracting 17, but then I'm going further than that. Okay, so really I'm finding the difference between these two numbers. So I'm going to come off here to the side and do 53 minus 17. Well, let's see here. 3 minus 7 can't do that, so I'm going to borrow from my 5, treat that like a 4. and treat this like a 13. 13 minus 7 is 6. 4 minus 1 is 3. 36. Okay. So 17 minus 17 fourths minus 53 fourths. Well, I'm going into the negative, so I know my answer is going to be negative. You could also think the signs are different. I have a negative and I have a positive. When the signs are different, you take the sign of the one with the larger absolute value, which in this case is this one. So we've got negative 36 over 4, and then we would want to simplify it. Now in this particular case, in the examples that I chose, when I simplify this, one thing I notice, I'm like, ooh, 36 and 4. Both of those can be divided by 4. So really I could reduce this or simplify it because they both have a 4 in common. 36 divided by 4 is 9. 4 divided by 4 is 1. So really it's negative 9 over 1. Anything over 1 is just the number itself. So my final answer could be just negative 9. In that case, there's a lot of concepts that problem covers. Okay, if you haven't written these down, I encourage you to pause this video and write both of those down so that you have examples of what I just did. Okay? Number 3, find the value that makes the equation true. So I have negative 5 and 2/10 plus something gives me 0. Okay? Gives me 0. Well, really, if I'm at negative 5 and 2/10, whether I think about it in money or temperature, it doesn't really matter. But, well, how do you get back to 0? I would add the additive inverse, which would be positive 5 and 2/10. And that's it. Okay? So, additive inverse, that's what that's representing. Number 4, negative 2 and 3/7 plus 5 minus 1/7. Whew, that's a lot there, right? So first off, we could rearrange these to make it a little easier if we wanted, okay? Like I could pull this one over here because of the commutative property of addition. So I could do that if I wanted to. Being that I'm dealing with negatives though, I'm just going to go in the order that I have, okay? So let's see here. Actually, no, I'm not. I'm going to pull that negative 7 over. I'm going to do negative 2 and 3/7 minus 1/7 and then plus 5. Okay? So with this, there's a few things going on. One, we have mixed number. We do have common denominators, so that's exciting. We want those. That makes our lives so much easier. Right? But so like in here, negative 2 and 3/7 minus 1/7. So it's like subtracting more than what we had already. Normally we would be tempted to just do 3/7 minus 1/7. We can't do that here because of this negative. It's negative 2 and 3/7 minus 1/7. So really I need to combine them, giving me negative 2 and 4/7 plus 5. Okay? So for this part, I think what I'm going to do is I'm going to go ahead and convert them, mostly so you can practice it. I'm going to convert them to improper fractions. Okay? So to do that, remember we already did that up in number 2. We can do 2 times 7 is 14, plus another 4 gets me to 18. So I have negative 18/7 plus, and now this one, I can make it an improper fraction by putting it over 1. Okay? You can make anything into a fraction by putting it over 1, unless it's an irrational number. It's still going to be irrational. Okay? But then if I want these to be in sevenths so that I can add them, well, I need to multiply both of them by 7 then. So that would give me 35/7. Okay? So, now that I have them both in sevenths, and they're both improper fractions, they're much easier to deal with. Okay? Again, I encourage you to use that chart that shows the rules of adding integers, because that's what's happening right here too, right? We can ignore the sevenths for a second and think, okay, -18 plus 35. Well, really what we're doing, because the signs are different, we're finding the difference between the two and then taking the absolute value, the sign of the number with the higher absolute value. So that's this one here. So we know we're going to have a positive answer. But first we need to figure out, well, what is the difference between 35 and 18? Well, 5 minus 8, I can't do that. Okay, so I'm going to borrow and treat this like a 15. 15 minus 8 is 7. 2 minus 1 is 1. So I'm left with 17/7. Okay, 17/7. And now I just need to convert it into a mixed number. So I need to think to myself, well, how many times does 7 go into 17? Okay, you can just count by sevens, right? We got 7, 14, 21. Ooh, 21 is too high. So I was only able to use 2 sevens before going over. And that got me to 14. Okay, well, how many more do I have left over till I get to 17? 3. And use my same denominator. Okay, so that was that right there. Notice, you might have thought, ooh, it's going to be 4/7, but it's not. We had to subtract, or well, find the difference between that and the 5, right? So our final answer is 2 3/7. All right, that was a lot. Pause that video, write it down. Okay. Number 5. During a game, a player gets 3 points for every correct answer and loses half a point for every wrong answer. What is the score for someone who got 6 questions right and 5 wrong? Whew. This kind of combines a lot of things, right? So first off, correct answers. Let me switch colors here. Oh, I don't know if that'll show up. Hold on, sorry. Let's see, so this right here, we've got 3 points for correct answers, right? And this person got 6 correct. So, how many points would that be? You could either add them up over and over again, but that's the same thing as multiplication. We could do 3 times 6, right? So we could say 3 times 6, well, that gives us 18 points so far. But now let's think, loses half a point, right, for each wrong answer. And in this case, this person got 5 wrong. Ooh, so what, if I have 5 halves, what does that give me? There's several ways that you can figure this out. You could do 5 times 1/2, which we really haven't talked about yet. Or you could set up 5 halves, add those up, right, to figure out how many points were lost, right? In this case, let's see, 1/2 plus 1/2 is 1 whole. Well, here's another one, 1/2 plus 1/2 is 1 whole, right? Do that and just take it one step at a time. 1 plus 1 is 2, plus 1/2 gets me 2.5. So 2.5 points are gone. If you were to do it this way, well, we could do 5 times 1 is 5, 1 times 2 is 2. 2 goes into 5 2 whole times with 1 left over and the same denominator. So either way, we get to 2.5. But the thing we need to consider, since this is like a real life situation, right? Technically, these are negatives because they're losing them. They're being subtracted from their score. So I'm not done yet. I haven't actually figured out how many points were earned. I need to think now, well, they gained 18 points, but they lost 2.5. Hopefully you can do that in your head. Hopefully you can think, okay, well, 18 minus 2, let's see, that gets me to 16, but then there's a half more. What's a half less than 16 is 15.5, okay? Now, if you can't think through that, that's okay. Let's use fractions. We can say, well, 18 as an improper fraction would give me 18 over 1 minus, and then up here, we had that improper fraction. We could say minus 5 halves, but I don't have a common denominator yet. So I need to think, okay, what's a common denominator between 1 and 2? Times 2 times 2, right? 2 times 1 gets me to 2. Whatever I do to my denominator, I have to do to my numerator. 2 times 18, well, that's 36 over 2, minus 5 over 2. Okay, well, 36 minus 5 is 31, same denominator. Convert it back to a mixed number. 2 goes into 31. Oh my goodness, you could write it out, you could count by 2s, right? There's different ways for you to work on that. Or maybe you understand that 2s are cutting something in half. 30 cut in half is 15, right? So 2 goes into 31 15 whole times. That gets us to 30 with 1 left over and the same denominator. Okay? So the final question was, what is the score for someone who got 6 questions right and 5 wrong? And we could say 15.5 points. Okay? So there's a lot going on there, but again, that process and understanding in a real world situation, how does this apply? That's what that question is getting at. Okay, number 6, what is the simplified fraction of 0 and 125 thousandths? So when it comes to converting a decimal to a fraction, listening to that place value, saying it out loud and listening to the place value is really important. So first off, 0, right? That means it's not going to be a mixed number. It's only going to be a fraction because everything is to the right of the decimal, okay? And notice I said 125, but then the place value was thousandths. That's also my denominator. So I can take my numerator and write it over the place value. The place value becomes my denominator. Well, if it's simplified fraction, that means I need to reduce this or simplify, or I need to look and see, do 125 and 1,000 have anything in common? They do, right? This number right here, actually, 25. If I count by 25s, right, I can think to myself, okay, well, 25, 50, 75, 100, right? That's 4 of them, and I'm only at 100. One more gets me to 125. So 125 divided by 25 is 5. Okay? All right, does that make sense so far? And then we've got 1,000 divided by 25. Well, let's use number sense in thinking, okay, I used 4 25s to get to 100. Well, how many hundreds get me to 1,000? That would be 10 of them. So I can think 4 times 10 gets me to 40, right? So there are 40 25s in 1,000. So, phew, so far I've reduced it, but one thing I notice is, it's still not fully reduced. Because if I have a number that ends in a 5 and one that ends in a 0, that means they could both still be divided by 5. So I got to take it one step further. 5 divided by 5 is 1. 40 divided by 5 is 8. This is my completely simplified fraction. Okay? You always got to think, what do they have in common? You have to be able to divide by the exact same thing, right? And maybe you recognize that 125 goes in there perfectly. If not, that's okay. Do what I did and just take it a little step at a time. Number 7. A recipe calls for 1 1/4 cups of sugar. You only have 2/3 cups. How much more do you need? Okay, so we're getting from one number to another. Sorry, my dog is barking. You're getting from one to another, which means you're finding the difference between those two, right? We already have a little bit. We need to get to the next part. So what we can do is, if we're going to find the difference between these, we're going to do 1 1/4 minus 2/3. Well, there's a couple things I notice. One, I have a mixed number, and I don't have common denominators, so I got to fix both of those things. First, let's convert this to an improper fraction. We're going to take our whole number, and we're going to multiply it by our denominator. 1 times 4 is 4. Add in your numerator. 4 plus 1 is 5. So that's 5/4 minus 2/3. Well, now I need to think, okay, I need a common denominator. So I need to think of a number that 4 and 3 both go into. There's a couple things you could do. One, you could count by 3s and count by 4s, like on the side of your paper, and see what is the lowest number that matches. Maybe you just know the smallest number that they both go into. You could use a multiplication chart. There's all kinds of different things that you could use. And worst comes to worst, multiply them by each other, and you will get a common denominator, right? Because 4 times 3 and 3 times 4 are the exact same thing. So that's what I'm going to do. I'm going to multiply them by each other. And technically that's the least common multiple anyway, so it works out in our favor. So 3 times 4, like I said, gets me to 12. 3 times 5 is 15, so I've got 15/12. Still an improper fraction. That's good, because this was 2, right? Well, over here, now I got to do 3 times 4. Whatever I do to my denominator, I got to do to my numerator. So I'm going to subtract, and then 2 times 4 is 8. 3 times 4 is 12. Nice. Okay, now they're both improper, well, they're not both improper fractions, but they're both in fraction form, not mixed number form, right? And they both have a common denominator, so I'm good to go on my subtraction. So I've got 15 minus 8. 15 minus 8 is 7, and then I keep my same denominator. 7 and 12 don't have anything in common, so that's my final answer. 7/12. But I knew that they were referring to cups. So in this case, I'm going to use cups. Now, that is an obnoxious amount of sugar, just so you know. If you're a baker, you know. Your measuring cups aren't going to have 7/12. So, but anyway, that gets you to the answer. Number 8. Mario has a statue that is 1/5 tin and 3/4 lead. Those are two different kinds of metal. The rest is copper. What fraction is copper? So in this case, there's a few things we need to know. First off, he has one whole statue, and it's made up of all these different things, right? So that's really important, because what we can say is that the statue is equal to a combination of tin plus lead plus copper. Okay? Well, let's put number values with each of those. If it's a statue, It's one whole statue. So I'm going to replace that with a 1. The tin portion, what did I say? 1/5? The tin portion is 1/5. The lead portion is 3/4. And then we don't know what the copper value is. So you could use a variable if you want. We could use the letter C to represent copper, right? That's our unknown. That's what we're looking for. Okay? All right. Well, now let's see here. 1/5 plus 3/4. Oof, no common denominator. So we need to first do that. We need to figure out, okay, what is the lowest number that they can both go into? Okay, and that is actually going to be where we multiply them by each other to get to 20. So I'm going to do times 4. Whatever I do to my numerator, I have to do to my denominator. I'm going to do the same thing over here. 4 times 5 and 3 times 5. Now I can rewrite my problem. So I've got 1 equals, then 1 times 4 is 4, 5 times 4 is 20, plus, and then we've got 3 times 5 is 15, 4 times 5 is 20, plus C. We still don't know what C is. But now that we have a common denominator, we can add those together. So 1 equals, 4 plus 15, that gives me 19 twentieths. 19 twentieths of the statue is already accounted for, plus C. Well, there's a couple things you can do. One, you might recognize, how many more until I get to 20 twentieths? Right? Because that's equal to 1, right? Let me write an arrow. 1 is equal to 20 twentieths. If I'm already at 19, that means C must be 1/20th. So 1/20th of the statue is copper. We also could have done 20 twentieths minus 19 twentieths, and we still would have gotten back to 1/20th. Okay? 2 more and then we're done. 2 more. Okay? Number 9. Which choice shows the additive inverse? 1, if you don't know what the additive inverse is, I suggest you look it up, right? Find that definition in your lessons. But also, we talked about it earlier in this video, so you might rewind and see that, okay? So, out of these options, 1, this right here, these symbols, these are called absolute value. So what that tells you, and what absolute value is how far away a number is from 0. So the absolute value of -6 is 6, okay, because it's 6 spaces away from 0. All right, so this is showing absolute value. It's not showing the additive inverse. Boop, those are gone. C is actually showing the exact same thing. This is showing absolute value. The absolute value, remember that's what those long lines are, of 5 1/10 is 5 1/10 because it's 5 1/10 spaces away from 0. That's absolute value, not the additive inverse. Okay? B, additive inverse. Inverse means like the opposite, right? So notice these are the opposites of each other, at least when you're looking at a number line. The opposite of -2 is 2, okay? Or that's what, like, if you were to fold the number line in half, they would line up with each other, okay? And so if you add them together, some people say, like, oh, they cancel each other out, or they equal 0. So B is a really good runner for the answer. For D, this is not showing additive inverse. This is showing 2 different properties. It's showing the commutative property of addition. I know that because the commutative property means you can switch the order that you're adding things in. And notice the 8 is in the front over here, and it's in the back over here, and same with the 2. And also, it's also showing the associative property. That means, like, I can throw in these parentheses and it still doesn't change anything. Okay? So those are other properties that are being shown, which in this case, B would be your final answer. Last one, we made it. Number 10, which expression represents the distance between the 2 points on the number line? All right. So this is like solving problems using absolute value, okay? The nice thing about a problem like this is it shows you the distance between them. So we know that we need to have a distance of 1, 2, 3, 4, 5 places between -3 and 2. So we need to solve these, and whichever one has an answer of 5, that's going to be our final answer. Okay? So I'm going to walk through these and show you how to apply them when you are using absolute value in an expression. So kind of like parentheses, it actually comes first. You have to apply the absolute value first, and then you can do the operations that follow it. So in this case, the absolute value of -3, well, that's 3, because -3 is 3 spaces away from 0. So really this is the same thing as 3 minus 2. Well, what's 3 minus 2? 1. Is there only 1 space between them? No, there's 5. We're looking for 5. Let's look at B. The absolute value of 2. Well, that's just 2, because 2 is 2 spaces away from 0. We have minus, and then the absolute value of -3. Well, like we talked about up here, the absolute value of -3 is 3. Well, now I have 2 minus 3. Okay, well, 2 minus 3 is -1, not 5. With this one, now the absolute value is kind of being treated even more like parentheses, because when you consider the order of operations, you have to do whatever's inside the parentheses first, okay? And in this case, we do have an operation inside the absolute value. -3 minus 2, well, that's -5. -3 minus 2 is -5. Now I can go ahead and apply the absolute value. Well, what's the absolute value of -5? It's 5, because it's 5 spaces away from 0. It's always a good idea to check every single answer. That's just a good test-taking strategy and a life skill. Check all of them before you just assume, right? So in this case, I have an operation inside of the absolute value symbol, 3 minus 5. 3 minus 5 is -2, and the absolute value of -2 is 5. No, just kidding. Oh my goodness. Miss Angel made a huge mistake. I was looking at that 5. The absolute value of -2 is 2. Holy moly, Miss Angel. Right? Because -2 is 2 spaces away from 0. So D doesn't work either, making C our final answer. Okay? I hope this helps. Rewatch it. Pause the video, write them all down, do all of those things, use it during your test. You might as well, right? And do your best. All right? And reach out to me if you need extra help beyond this.